Hi, my name is Muzaidul Islam and welcome to my YouTube channel. So today we are going to talk about the basic structure of a machine learning pipeline. As we all know, machine learning pipeline is very much essential for making our project to the production level. So without making any delay, let us talk about each and every component of a machine learning pipelines. So the first component we are going to talk about is the data ingestion component. So here we'll be defining the path where the data is stored, and then we are going to define the next component, which is the data validation component. So see, initially we'll be having the data from the client, or we'll be setting the client, we'll be sitting in a discussion and we'll be talking with the client that these are the features we require. So we need to do the validation if we are getting the right features or not. So we can say we'll check the schema here. We'll check for like missing values. We'll check for outliers, and we'll check if the data we asked and if it's fulfilling the criteria or not. And next step we're going to do is data transformation. Data transformation. Here, after data validation, we are also going to do the most important part, that is the EDA. Here predominantly we are going to use Jupyter here for doing the EDA. In EDA we are going to find basically all the insights that we can find from the data. So what the data says, we're going to make the data talk. After doing EDA we are going to do the transformations. So what do you think will fall in transformation? See, suppose the features are having is not in the same scale. So feature scaling can be a part of the data transformation. And like log transformation, box-cox transformation, these will all fall in the feature like data transformation pipeline. We'll build a pipeline and basically we'll pickle it, and we'll pickle this object, data transformation pipeline. And then after that we'll go into the next phase, which is model training. In this phase, we are going to train the model with the model training as well as hyperparameter training. We're going to split the data into train and test. We're going to split the data into train and test, and we are going to make sure that this train and test, like the data that we are going to train is not aware of what the data in test is, so that data leakage doesn't happen. Data leakage doesn't happen. Data leakage in the sense like that the test data should not have any clue how the trained data looks like. So it will be like we'll be trying to recreate the production scenarios, like if new data comes, how the new data will be. So we're going to test data, we'll treat the test data as the new data. Okay, then we're going to go to the next phase, which is model evaluation. In model evaluation, what we are going to do is like we're going to plot for like ROC AUC curve. We can plot and we can validate the model. Like see here, what will happen is that model pusher. Let me write completed model pusher. So suppose random forest. Let me give you an example. Suppose random forest. Okay, suppose random forest is in production. Now what will happen? Suppose the data we are like training, the new data is coming every day, and then new data will come, right? So this new data, suppose, are now not same. It's like different from the data we train on. So what is that? We'll have to capture a data drift. So this data drift is something in which we can say that the new data is changing. And so what will happen is that the model which we were trained in the production level, suppose random forest was in the production level, its accuracy may come down. A new model like logistic regression or any other model we can say may go up. So what will happen is that we need to retrain the model. So if this happens, then we are going to check it, the model evaluation. In this model evaluation stage and model pusher stage, what we're going to do is we are going to check the model that is in production and the other models which is giving better accuracy. So if we'll check which one was giving better accuracy, if our model, if we see that logistic regression is giving better regression, then we'll push it to the production level. So this is how our machine learning pipeline works.